Hello everyone. Today I am going to discuss the third problem of Leetcode Biweekly contest 151, which is find minimum cost to remove array elements. So what is the problem? We are given an integer array nums. We have to remove all the elements from the array by performing one of the following operation each step until nums is empty. So we have to choose any two elements from the first three elements and remove them. And the cost of the operation will be the maximum of the two elements removed. Okay. And if fewer than three elements are remaining, like two or one, then we have to just delete them, and the cost of this operation will be maximum of these elements. Okay, now we have to return minimum cost to remove all the elements. So let's take the first example, 6284. Okay, 6284. Okay, so what is the optimal way of removing this element? Okay, removing these elements. Okay, so let's say the let's take the answer. I don't remember. So we have to remove the zeroth and the second element. Okay, so we have to remove 6 and 8. Okay, if we remove 6 and 8, then the cost will be 8. Okay, because the maximum of the two elements removed, and then 2 and 4 are remaining, so the maximum of this 2 will be 8 plus 4, which will be 12. So the maximum cost is minimum cost is 12. That is the optimal way to remove the elements. Okay, now you might think that we have to take the maximum element and the second maximum element and just remove them, but that is not the case. If we take the second example, 2133. Okay, so let's take the second example, 2133. Now our algorithm says that remove the maximum element and the second maximum element. So let's remove 3 and 2. Okay, so the cost will be 3, and now we have 3 and 1 remaining. The cost will be again 3, so the overall cost is 6. But this is not the optimal way to remove the elements. Okay, so 2133. Okay, so let's say in the first operation, let's say we have removed 2 and 1. Okay, let's say first operation we have removed 2 and 1, then the cost will be 2. And in the second operation, let's say we have removed 3 and 3, then the cost will be 3. So the optimal way to remove this element is this, like this only. So after seeing this problem and thinking about the logic, you might think about we have to find some greedy approach by sorting or something, but that is not the correct way to solve this problem. Why? There may be solutions like greedy solution, but that is not needed. Okay, because the complexity, because the constants. So here constants on nums is 1000. Okay, constants on num is 1000. So order of n square is also accepted. Order of n square log n is also accepted. Now whenever order of n square is accepted and we have something like this, like three elements, so we can think about some dynamic programming approach with recursion. Okay, so if we think about recursion, okay, let's forget about dynamic programming, let's think about recursion. Then what will be the recursion steps, like the transition and the parameters of the recursion state? What could be those? Okay, now so we have three elements, right? Now whenever we are removing two elements, then there will be only one element left. Let's say we are at some index I. Okay, some index I, we are at some index I. There will be some value L, or last you can say there will be some value L somewhere before I, and there will be I plus 1. So we will consider I plus 1 and L always. So we will be always considering I plus 1 and L, because let's say this is the case, right? Now if we remove L and I plus 1 will remain. If we remove I and I plus 1, L will remain. And if we remove I plus 1 and L, I will remain. So only one element is remaining, and the three elements will be L, I and I plus 1. Now if we only take these two parameters, L and I, then we can solve this problem. So our recursion parameter will be L and I only. Recursion parameter will be L and I only. Now from L and I we can go to three different recursion state. Okay, three different recursion state. So in the first step, let's say we have removed L. We have removed L. Sorry, we have removed L and I. Then our last element L will be nothing but we have removed L and I, right? Then last element will be I plus 1. So the recursion state will be I plus 1 comma I plus 2, because now we have up in each step we will go to I plus 2, right? In each step we will go to I plus 2, right? Because we are removing two elements. So our next element will be I plus 2. Now let's say we have removed I and I plus 1, then our recursion step will be L and I plus 2. And let's say we have removed L and I plus 1, L and I plus 1, then our recursion state will be I and I plus 2. Okay, so these three recursion states we can go, and each recursion state this will be added with maximum of the removed elements. So this is just straightforward DP with order of n square. This problem is very straightforward. So let's jump into the code directly. So here is the code. If I equals to n, that means we have taken all the elements and we have jumped to the end, then only last one element is remaining. so we'll just take that element. Okay, only one element is remaining, which will be L, so we'll just take that element. Okay, this will be the one base case. And this part is for memorization to solve this problem in order of n square, so just ignore this. I think all of you know about recursion with memorization. We have to just take the recursion parameters and add the state in a map. Okay, you can store the recursion state in a map, so just ignore that. Only the transitions are important, and calculating the total number of recursion state is important. The rest of the part, memorization part, is quite straightforward. Okay, now if I equals to n minus 1, that is another case. Okay, I equals to n minus 1, then this I plus 1th element does not exist. Then in that case you have to take the maximum of L and I. Okay, you have to take the maximum of L and I. This is another case. Okay, there are two edge cases here. Okay, if I equals to n and I equals to n minus 1. Now here is the three cases. So in the first case we have removed I and I plus 1, so our last element will be same as the previous last. And in this case we have removed I and last, then our last element will be I plus 1. And in this case we are removing I plus 1 and last, our last element will be I now. Okay, and here I am starting at the last element is 0 and the current element is 1. That's how I am starting my DP. Okay, 0, 1 and nums. So this problem is quite straightforward. I hope you got the explanation in the code. If you still have doubt, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you for watching.